is a cesium, and then the yellow one is a chloride. So from here you can see that the corner of the chloride will become the center of the cesium. See that? This is actually the corner of this chloride. But then when we build the structure, when we combine all the unit cell, then you can see that this yellow chloride become the center of this cesium. At the same time, the corner of the cesium will become the center of the chloride in 3D. It's a little bit difficult for you to imagine, but you try to think about it. Therefore, although it looks like body center cubic, but if you look at this carefully, then you will find that actually it's just combination of two simple cubic. See that? We have one simple cubic of the yellow one, simple cubic, and then the other simple cubic of red one. See that? So this actually explains why the underlying graphite lattice is simple cubic but not body center cubic, although it looks like body center cubic. Okay, because we need to apply the concept of basics. Same thing apply to the 2D. So this is the unit cell that I draw. But if you don't like, you can also link all the blue atom. And now you see the corner of the blue atom become the center of the orange unit cell. The corner of the orange atom become the center of the blue unit cell. When you consider the red, when you consider the orange and the blue become one basic, then you will find that this is actually simple cubic. I hope you are clear about this lah. Okay, because I spent many time, I spent my time to prepare all this figure and explanation. Okay. Then the next question, why the number of nearest neighbor is 8? When I ask why the number of nearest neighbor means it can be different type of the atom, but nearest neighbor basic, then it should be the same type of the atom. Okay, so for the cesium chloride, just like the sodium chloride structure, the cesium, the chlorine frame is displaced by 1/2 of the body diagonal of the conventional unit cell. Here, the nearest neighbor distance is that between the Cl at the center of the cube and Cs ion at one of the cube corner. Therefore, there are 8 nearest neighbor. So you can see from this one, if I ask you, what is the nearest neighbor for this blue atom? Then of course it's 1, 2, 3, 4, 5, 6, 7, 8. Right? Then how to find the distance? Then we know that from this point to this point is half A. Okay, sorry. From here to here half A, here to here half A. So here to here is hypotenuse lah, S lah. Then from the middle to here is half A. Then you can get another hypotenuse Y. So you can get the distance between the center atom or center lattice point with the corner lattice point. So center lattice point with the corner lattice point for the precision chloride, this is the nearest neighbor distance. Okay, so for sodium chloride structure, it can be one Bravais lattice that composed of 4 basics. Okay, it can be Bravais lattice composed of 4 basics. Okay, yeah, first option. The second option, if you don't like to use the concept of basic and you want to look at it by using the atom, then you can see that it's actually composed of 2 non-Bravais lattice, 2 FCC sublattices, and then both displaced by half A. And then the first one composed of 4 sodium chloride, sodium atom. The other one composed of 4 chlorine atoms. Same thing applied to the cesium chloride structure. So for cesium chloride structure, it's a Bravais lattice that composed of simple cubic lattice. Okay, in the crystallography definition. But if you don't like, you say that, okay, I want to examine it through the atom, which is not conventional. So if you want to examine through the atom, then it's a non-Bravais lattice composed of 2 simple cubic sublattices and displaced to each other by square root of 3 over 2a. You can calculate the distance between this one and this one. So this is how much it has been displaced. Okay. So one makeup of one cesium chloride, cesium atom, the other one chlorine atom. Why 1? Because 1 over 8 times 8 equal to 1. The contribution equal to 1. So you get that equal to 8. Okay. So just now I explained the simple structure like iron, magnesium, which only have one component. Then there are FCC. I also explained that there are 12 nearest neighbor. And then 4.2, I explained the structure of the sodium chloride and NaCl garam. And then 4.3, I explained the structure of the cesium chloride. It looks like body standard cubic, but in fact it's a simple cubic. Okay, so now number 4.4, section 4, I will introduce you the closed pack structure. If you remember in the first chapter, we actually, second chapter, we actually work out the packing fraction for the simple cubic, body center cubic, and then the face center cubic, right? Remember during that time, I told you that the packing fraction for the FCC is the highest, and which is 74%. Okay, so 74%